Okay, welcome everyone to be here. It's my great honor to moderate this talk. I found most people from mechanical, I'm from civil. So, okay, so it's a great honor. We have our speaker, Dr. Kenneth Leung from Environment and Ecology Bureau, the government. So Dr. Leung was trained as a mechanical engineer and obtained his PhD in combustion science from Imperial College London. He joined the Environmental Protection Department in 1998 as an air quality modeling specialist and tasked to develop a regional air quality model named PATH for Hong Kong. So during his career in the environmental protection field, Dr. Leung was developed expertise in air pollution modeling, environmental impact assessment, and air quality management. So Dr. Leung's current position as a Principal Assistant Secretary for Air Policy in the Environment and Ecology Bureau and is responsible for developing policies to improve air quality, promote new energy transport, and formulating EV charging strategy for Hong Kong. Let's welcome Dr. Leung to give a talk.
Thank you for inviting me to this talk, and in particular, I have to thank Professor Leung. We work very hard in the past few years. Last year, a little bit relaxed because Professor Lee's team helped the government to conduct a lot of tracer gas experiments during the COVID, the 3 years of COVID, because I was responsible for leading the team to do a lot of outbreak investigations, and just so happened to have the help from Professor Lee to really find out the transmission pathway for those outbreak situations. And today, I would like to share with you some of my experience in combining scientific know-how into policy making. Because you may heard a lot about the Climate Action Plan, because in many talks, my colleagues, my bureau's secretary, they actually share a lot of relevant policies in this particular aspect. But I would like to share more about what's going to happen next. What other policy that in the making that we want to bring into the society that will have further impact to achieving the climate action plan's timeline. And this is very familiar picture at the top. Why we are concerned about the climate change or the use of fossil fuel is simply the impact of climate change is become so close to our home now. Because every year, we will experience extreme typhoon, heavy rainfall. It continuously happening in the past 4 to 5 years. I mean, number 10 typhoons almost happen in every year now. And sudden outbreak, pour down of heavy rainfall, it's just unpredictable. And I mean, flooding, it just became one of the disasters of this year. And that's why it became something the government has to look at it seriously. It's not just to predict what's going to happen. We also need to make some kind of action whenever we know that similar disaster may happen. So what kind of reaction, what kind of actions that we need to take in order to minimize the disaster towards the human life as well as towards our infrastructure. So the HKO actually doing something now to do together with the DSD to predict what's going to happen in next year and what kind of emergency action we need to, or plan, we need to plan for. But in fact, if you look at all over the world, how to mitigate climate, a simple solution is to use less fossil fuel. And you probably heard that in the COP28, a lot of discussion about reducing the use of fossil fuel. It's not easy to have a consensus, and in particular for the oil-producing countries, because that's their lifeblood. And it's not easy to really stop using the fossil fuel. But it has to happen. And that is the direction how Hong Kong government formulate our policy to make it happen. It's easy to talk. We can actually set the timeline, but how to make it happen? And that's why I would say policy for climate action is a matter of how and when. How to make it happen, and when to make it happen. Okay, timing is important. Even though you may have brilliant technology, but because it's too expensive, not economical, it may not be feasible for the society to take it on at a certain period of time. But if you wait a little bit later, it may become viable and become more mature to adopt. So this is the question. This I put down here. Everyone's going forward to give out a timeline when to phase out fossil fuel car, when to use sustainable aviation fuel, when to use biofuel for the marine sector. Okay? They can set the timeline, but are they really make the effort to put in large-scale application? That's the issue. Now, for our country, President Xi made the two timelines. That is by 2030, we have to reach the peak of our carbon emission, and by 2060, the country has to reach carbon neutrality. Hong Kong also has our timeline. The two time frame is here. By 2035, we want to reduce our carbon emission by half as compared to the level at 2005. Because we already reached the peak in around 2014. So we are coming down already. So we set a midpoint to gauge our achievement. That's the midpoint is 2035. We want to cut half at least from the 2005 level. Then we will proceed to reach the 2050 carbon neutrality target. So by setting these two timelines, the government have to sit down and think it through clearly how to achieve it. It's not just a number that we put down here. It's something we need to plan for. From now to 2035, we still have around 12 years. So this is something we can plan what we need to do in the next 10 to 12 years' time so that we can achieve this target. And in fact, Hong Kong is lucky because if you look at our carbon footprint, if you look at here, it's not that complicated. We don't have heavy industry. And majority of our carbon footprint come from the power generation, so it's 60%. Within this 60%, 90% of the electricity was used in the buildings, okay? For the lighting, for the lift, for the air conditioning, for all kinds of application inside the building. And then about 20% of our carbon emissions come from the transport sector, either road-based or sea-based emissions. The remainings are mainly come from the waste management. Now, why is it waste management? Because all our domestic waste, municipal waste are now just simply buried in the landfill. When you put the rubbish in the landfill site, and then it will ferment and generate methane. Methane is a greenhouse gas. It not necessarily need to be carbon dioxide. Methane's greenhouse gas potential, someone say it's 40 times, someone say it's 80 times. Doesn't really matter. It's just many, many times above CO2, okay? So we want to cut down the methane emissions from the landfill site. And that's the reason why the government also set certain timeline to phase out landfill. That I will introduce later on. And as a result from this carbon footprint, is a signature footprint for Hong Kong. It may not be the same for other countries or other cities, because other cities, especially in mainland, there are cities relying on heavy industry. Their economy is relying on heavy industry. They will have significant contribution from the industry. But because of our own signature footprint, we designed 4 strategies to achieve the target that we set. Basically, we want to transform our power generations from currently relying on fossil fuel to eventually net zero. That means whatever fuel we are going to use in future for power generation, it has to be carbon-free or carbon neutral. And then this is on the supply side. We also need to deal with our demand side to reduce the power consumption from our building. That means to improve the energy efficiency and also to construct more green buildings. The third one is to promote green transport, eventually transform our land-based and sea-based vehicles as well as ships into using either electricity or other type of carbon-free green fuel. And fourth, we have to make many plans to reduce our waste. In particular, next year, we will start the municipal waste charging scheme in April. So we want to really make use of fiscal measures to encourage the whole populations to join force to reduce the amount of waste production. Now, it's interesting how to calculate carbon emissions. For me, it's not too difficult. It's a simple question. As long as you dig out something from the ground, which has been buried for millions of years, and release it to the air, that's carbon emission. No matter what means that you use, whether it's solid form, gas form, or what other composite form, you burn it, you convert it into another form. As long as this is not in a solid form, it's a carbon emission. And some people say, okay, I turn my petroleum into plastic. Okay? It's not generating any carbon. And then the question is, how are you going to treat that piece of plastic? Are you going to keep on transforming it into solid form? Or you burn it in the incinerator, that becomes a gas phase molecule. So how I count is whether you convert a solid form carbon molecule into a gaseous form carbon molecule in a CO2 form. If you proceed along this pathway, you account for carbon emission. Now, that's another. I emphasize that the solid form that you dig out or gas form that you dig out was buried millions of years ago. What about I burn down a tree? I cut a piece of wood, I burn it. Is it carbon emission or carbon neutral? That piece of wood or that tree is only available for the past 10 years. It has been absorbing the CO2 from the atmosphere for the past 10 years. You burn it, you just recycle the CO2, which has happened in the past 10 years, back to the atmosphere. Now, that is an issue about time. How long was the carbon being locked up in the earth? And also, how short in terms of time that you release it? So it's engineering. It's a rate of change. It's the rate of change. Because you're releasing the CO2 too fast, that's why our atmosphere could not really accommodate that increase naturally. And that's the reason why we have this greenhouse gas problem. So, because a lot of propositions in the trade to talk about, I do carbon capture, I do this and that, I do compensation, I emit carbon in this city, and I compensate it in the other continent. It doesn't work. Personally, as a scientist, I don't accept this. It is some kind of carbon trading. But I would like to put it in a more pragmatic way. So the best way is to reduce the use of fossil fuel, okay? And if you can't avoid using fossil fuel, you still have some carbon emission, then you have to find some means to capture it. When you capture it, it has to be locked in a solid form that could be buried back to the ground again. So this is how I interpret this balance. However, when the amount of renewables, actually the proportion of renewable energy start increasing around the world, so you will have much cheaper access to renewable energy. That means green energy. And in fact, this chemical process of making use molecule whatever molecule, to combine it together to produce synthetic gas is a very mature chemical industry already. They already exist. It's just a matter of whether you have access to cheap, a very competitive price renewable energy. Once you have very competitive price renewable energy, you can use it to generate hydrogen. From hydrogen, you can combine it with whatever molecule you want to generate the synthetic fuel that you want to use eventually. So that synthetic fuel, I would treat it as carbon neutral fuel because the carbon was captured from the atmosphere or from other sources that generate the carbon, the CO2. Okay? So virtually in the next 10, 15 years, people are going towards this direction to generate some carbon neutral fuel to fulfill the user's requirement because some of them could not get away from combustion. So they still have to rely on some kind of hydrocarbon fuel. But their source of fuel will not be coming from the ground. The source of the fuel would be produced in a chemical plant through green energy. This is the fuel mix for Hong Kong's power generation. So at the moment, we use around 50% LNG for power generation, 25 rely on coal, and another 25 relying on nuclear power. If you go back like 10 years ago, our proportion of coal is much higher. It's over 50%. We progressively reduced the proportion of coal, and that's enabled us to reach this 50% LNG proportion. If you look at the average carbon intensity, and this is the three figures, and then we can work out about 0.44 for Hong Kong. And if I compare with other countries, we are in a pretty good positions at the moment, even right now. Of course, we could not compare with France and Norway. The reason why? Because France uses a lot of nuclear power. Majority of power generation are depending on nuclear plant. And in Norway, 80%, almost 80% are renewables because they have very good resources for wind power and hydropower. So they rely on renewable heavily. And that's why they can keep the number below 0.1. And what will happen if I remove coal from our power generation? If I remove coal from our power generation, that means our carbon intensity will go down below 0.3 easily. Easily. And based on this type of analysis, we propose this kind of action that the Hong Kong government will do in future. So we will shut down the coal power plant by 2035. So no more coal fire by 2035. We will replace it by more LNG power generation units. So you heard it from the news. During a recent development plan, we actually approved the construction of new LNG units to cater for the future demand. We'll increase the supply of nuclear from mainland. Okay? It will not be 25, it will be more than 25 in future. And also, we will increase the proportion of renewable energy from Hong Kong ourselves. Now, Hong Kong is not famous for good renewable energy resources. In fact, we just turned down the proposal of building a wind farm by the two power companies in Hong Kong. If you think about the Hong Kong area, the water area of Hong Kong is very limited. We don't have a large area of water we can enjoy to build a wind farm with large scale. If you go beyond Lantau to the southern part of the water, it's not belong to Hong Kong. It belongs to Zhuhai. It's better to build the wind farm outside and supply electricity back to Hong Kong. It's cheaper and then also in scale. And that's the reason why we turned down the proposal from the two power companies. And we would rather them to invest in something cheaper in terms of reduce the carbon footprint. And so there's some timeline. So I would just want to recap. This is the new unit. I actually should be finished by now. This is a COP Leung gas unit. So by 2035, we will phase out coal combustion. We will increase by 35, increase the RE share from 7.5 to about 15%. That is more or less the maximum that we could do, relying on ourselves. And also, in the future, we will trial more regional collaboration. That means importing electricity, green electricity, from across the border. And the power company will also start trying out hydrogen. Now, it is not easy to try out hydrogen now. Think about it. The supply of hydrogen is not stable, and it's very expensive. So, and all the gas plants, majority are just recently built, just start operating for less than 2 years. So, it's not financially viable. They invest billions of dollars for a plant, and you tell them to shut it down in 15 years' time and convert it into hydrogen. They're happy to do it, but the citizens are not happy because you have to pay for it, because of the scheme of control. Every dollar that the power company invests, they will generate guaranteed 8% return. So they're happy to invest in whatever you want them to invest. Invest billions of dollars, $100 billion, no problem. They just try it out. But from the government point of view, we will not allow this to happen. We want the electricity price to be affordable to the general public. And that's the reason why we keep a close look on the development plan and have very close control of it as well. And in order to enable the import of electricity from outside of Hong Kong, you may recently heard about this reclamation plan at Zhangguanou. Basically, we have 2 reclamation areas. Area 132, which is currently outside the landfill site, will be used for housing development. The other one, which is right outside the cemetery, this is a new piece of reclaimed land. And this piece of land is about 25 hectares in terms of size. And that piece of land will not be used for housing development. Will only be used for developing different utilities applications. For example, public fuel, housing a concrete batching plant. In particular, we're going to put future electricity facility on that new land, reclaimed land. That will cater for, if I have subsea pipe cable line coming from this area, it will directly go to Zhangguanou and then distribute through the existing grid. And this is easier because that is an easy entry point for Hong Kong as compared to other areas, because that can come down from the eastern part of Shenzhen quickly. Although we have limited resources, but we will try to maximize our RE potential. One particular application is make use of our reservoir. Actually, a reservoir has a large piece of water area, and since 2017, we have started testing our building. This is something like 200 kilowatts, very small, okay? To try out the generation of solar power from the reservoir to see how it can be utilized. And based on that experience, the government actually proposed in this year's policy address to start constructing a 5 megawatt solar farm at Plover Cove Reservoir, the one at Tai Po, okay? That will be bigger. Even 5 megawatt will not use up the water area. I was slightly involved in this project a few months ago, and I was on the site to see the size of the reservoir. We calculate it could actually build a 100 megawatt solar farm on that particular reservoir. It's big enough to build a 100 megawatt. But we will start to 5 megawatts first to see the scale and how to utilize the electricity. Because you generate so much electricity, you could not actually ship it out for other people's use. It's a waste. At the moment, the infrastructure is not capable to handle more than 7 megawatt, okay, for the whole area of Taipo. It needs upgrading of infrastructure before we can try something bigger. Okay, and similarly, we make use of via NGO and school and the private sector to build more solar panels to generate electricity that they can, through the feed-in tariff scheme, they can sell back to the two power company at higher price, and so that will cover part of our commitment in terms of renewables. In terms of energy saving and green buildings, we set some achievable targets. For example, by 2 years' time, we want to increase the performance by over 6%. And then it's mainly on government buildings. And because we know that the government ourselves can actually move faster than the general public or even the private sector. We don't need to wait for legislation. I can just write a circular, and then all government buildings need to comply. It's a simple way. So I'm doing this type of work now, just writing circulars from time to time and telling people what to do. Okay, and so eventually we want to push up the performance by reducing 30 to 40% of the current existing power consumption from commercial building. And on top of it, we are building quite a lot of this DSD district cooling system. In particular in Kai Tak, in future in the Northern Metropolis, we will do something similar so that it's like a shared water cooling system to enable the commercial buildings to reduce the power consumption for air conditioning. Because you use the water to take away the heat, okay? It's just a heat transfer system. So then in future, the building will not need to rely on air cool for their chiller. They can use water cool to cool down their chiller. Now, finished the power sector, I come to the new energy transport part. Whenever we talk about new energy transport, basically, the propulsion part, you only have 3 choices. You could not get away from these 3 choices. So traditionally, we rely on internal combustion engine, ICE. And now we have fuel cell. Okay, that's the energy, the power system. And then EV basically rely on pure battery. So you have these 3 power sources. But then what kind of fuel you are talking about? There could be many types of fuel alongside traditional fuel. You can put all this fuel into the internal combustion engine, burn it. Okay? You can also put this fuel into the fuel cell, because the fuel cell can actually split the molecule to get the hydrogen out and to drive, eventually to drive the electricity generator. So we have all this combination right now. They are the most interesting type of fuel we are looking at. But are they all viable? In order to consider whether they are viable, I will put down 3 criteria. The price, how much it costs per unit or per liter or per kilowatt of this type of energy, and the availability of this type of fuel. Is it easily accessible, stable supply? And then how long does this take for refueling? And this is the basic questions actually challenging both fuel cell and pure battery, because battery vehicle, people are complaining they need a long time to recharge it, and that's the reason why people are advocating hydrogen. Okay, people are advocating hydrogen because the hydrogen refueling time may be within 10 minutes, similar to fueling up a petrol car. However, currently, I just opened up the first hydrogen fueling station in Hong Kong, which is going to be built by Sinopec. They are going to charge you $108 per kilo. That's if your car needs 5 kilo, it's okay, 500 kilo. For petrol car, it's cheaper, but it's a lorry. You need about 25 kilo per day to run. That means you pay over $2,500 per day, which is much more expensive as compared to diesel. So at the moment, hydrogen is not economically viable. It's technically feasible. It may have shorter refueling time, but the fuel cell is expensive, and then the hydrogen fuel itself is expensive. When you talk about methanol and ammonia, I'm not looking for gray methanol, gray ammonia. I'm talking about green. That's being produced from renewable energy. Even more expensive than hydrogen and short supply as compared to hydrogen. It's not that easy to produce, and everyone are fighting for it. In particular, for green methanol, I will touch on later about for the marine sector. On this slide, I try to show you the progress of uptaking of EV around the world. If you move the timeline before 2015, the number of electric vehicles around the world is very, very limited. And in fact, the whole uptake of EV only starts since 2016, 17. It's picking up very quickly in the last 7 to 8 years. And because of a famous tea brand, they start really putting in a viable consumer EV product that's acceptable by the customer. And since then, the uptake is very obvious. And now China is virtually the top market player. They actually China owns the highest number of EV in the world and also produce the largest number of EVs in the world. And the reason why I want to put down in this graph is to compare the number of EV, electric vehicle, as compared to the number of hydrogen fuel cell vehicle. I would say the development of hydrogen fuel cell vehicle right now, at this point of time, is pretty much 10 years ago of the development of EV. So it is just at the beginning. It's still far away from the uptaking point yet. May still need 5 to 8 years' time for the hydrogen fuel cell technology, the hydrogen supply itself to be viable so that the uptaking could speed up eventually. If I come back to Hong Kong, what have we done? In 2018, we introduced the first registrations tax concessions arrangement to encourage the uptaking of EV. And in fact, it's quite generous. If you go for the one-for-one, you can enjoy, at the moment, 287,500 tax reduction. Okay, it's a very generous subsidies, I would say. And because of that scheme, and you can see the uptake in double almost every year. And last year, the whole year sales is over 50% were EV. This year, it's over 64%. So the market already sold over 200,000 electric private car this year, much more than last year. And we expect this continue in the next few years because progressively we will resolve the charging issue because the government put in a lot of efforts to help out the society by putting down, we allocate 3.5 billion to help over 700 estates to construct EV charging infrastructures. So by the time of 2027, we finish this project, we should be able to enable 140,000 car park space equipped with EV charging facility. That means we could actually entertain the growth for the next 5 years. At the moment, we only have 65,000 EVs in Hong Kong, and so we could allow for another 80,000 growth in the coming 5 years. It should not be a problem. And also in 2021, the government issued this blueprint for roadmap for popularizations of electric vehicle in Hong Kong. In this roadmap, in particular, we set a date, again, timing. We set a date by 2035 or even before, I have to say, we will stop the registrations of fossil fuel vehicle from that year onward. That means you cannot sell fossil fuel vehicles in Hong Kong anymore by 2035. You can only buy new energy vehicles by that time. And this is a very clear message to the trade. So they know that they have to start transforming now, okay? Or start planning for the transformation. Otherwise, they will lag behind. And also, we set a target by 2050, it will be zero carbon emission. That means the vehicle will not be relying on fossil fuel again. So, same time and how we do it, okay? How? By setting legislation, and time, we set the timeline to let the public know. And this graph illustrates the change of the growth of total private vehicles as well as the growth of EVs. You can see that the growth of EV in Hong Kong starts from around 2017. Okay, it starts picking up very quickly. At 2018, we start this 1-for-1 scheme. And the good thing is 1-for-1, what does it mean? You have to deregister an old petrol fuel, car. Okay, that means it maintains the total number of vehicles not growing too fast. And in fact, from a statistic, say for example, last year we sold around 20,000 EVs. 98% of the buyer actually make use of the 1-for-1 scheme. That means almost we deregister over 19,000 vehicles at the same time when we acquire 20,000 EVs. So that's the ratio. And that helped to actually make the growth slow down and now even coming down now. Okay, without this 1-for-1, we expect it will follow the orange line. It will keep on growing. But with the 1-for-1 scheme, we were successful to keep the vehicle growth at a manageable level. Now come to the marine sector. This is the time chart published by IMO, International Maritime Organization. So previously, if you go back before 2020, IMO mainly focused on improving the performance of air pollution. They seldom talk about the carbon emissions. So they issue directives that different year you build a ship, you have to comply with a certain air pollution emission standard. But from 2020 onward, they start looking at the greenhouse gas issue. And right now, they even, in the COP28, they set some new target as well. The whole marine sector has to start thinking about and planning for how to cut down their carbon footprint. And eventually, they set target for 2030 and 2040. If you look at the 2030 target, they ask for 40% reductions in the carbon footprint. This is a substantial cut for the marine sector. The reason why, when you build a cargo ship, it normally lasts for 20 to 30 years. So the ship liner are now all planning for new ships building. And they are looking for what type of fuel they're going to use. And interestingly, the most favorable one right now is not LNG. LNG is something built in the past 10 years. And the new builds are mainly will run on both diesel and methanol. They want them to be methanol ready. So they don't need to change their engine anymore. So once they can buy green methanol from the market, the ship liner can shift to the green methanol channel easily. And the other reason is because the various ports are talking about carbon tax. If the route is, or the ship that you're going to use to transport the cargoes are not running on greenfield, your carbon footprint will be pretty high and may very easily exceed the allowable limit. And then for each piece of cargo, you have to pay extra tax. So the trade is gearing up for this transformation. And so they are building new ship. At the same time, they are looking for new greenfield as well. Right now, the two candidates are methanol and ammonia. And methanols are coming much more favorable at the moment. Ammonia just in the pilot, 1 or 2 boats being built to run on that type of fuel. A lot more on methanol, because for methanol, the engine itself can run both methanol and diesel. It does not need to do any modification. You just need to modify the tank. The tank needs to be lined up with a special liner to prevent the corrosive property of methanol itself. So once you design your ship with that capability, then you can actually switch the fuel very easily. And so because of this change in the marine sector, what will the Hong Kong government do? And a few years ago, we approved the offshore LNG terminals construction. So the construction work actually completed. It will start and also officially start operation at the end of this year. So already functioning, okay? They actually can receive the first shipments of LNG. And on top of this, we have been discussing with the tourist commissions. The cruise liner industry also have a very severe pressure on reducing, cutting down the carbon footprint. So in the future, we will construct the shore power for the cruise terminal in Kai Tak to enable the cruise liner to use shore power instead of burning the LNG or diesel on board. We will start the amendment work for the relevant marine policy to enable green marine field bunkering in 2024. Because right now, the regulations is very limited. It's only points to diesel. It's actually road diesel in the law. So we have to amend the law such that that name could be, will be transformed to just fuel. No need to be so specific as one particular fuel. So we will do the law amendment work next year. So after we amend the law, then we can conduct LNG bunkering as well as methanol bunkering very soon. There are some KPI that we set. We will start to test out the hydrogen vehicles. So we already opened up the hydrogen double-decker. You read the news, one of the bus company, because I work on that project as well, to ensure the design of the hydrogen double-deck bus could really met all the requirements from EMSD as well as the FSD, the Fire Services Department. And we'll test out 4 electric ferries in Hong Kong, and we will increase the number of parking space with electric chargers. We will introduce at least 3,000 e-taxi and 700 e-buses into Hong Kong service in the next few years. Now, come to the last part about waste. If you look at this sign, this is a very famous design by Hong Kong EPD, the 6th shop. 廣東話綠仔店 it's 諧音綠 6 means green, okay? They sound like green. So that's why they brand this particular name. So we will increase a lot more 6 shops around the societies in different districts. So to enable the sorting of rubbish, of waste. Because in order to manage our waste properly, you need to have good sorting system, waste separation. You can't mix the waste together and then do good recycling afterward. It's not possible. That's why we want to really enable the society to do waste separation, sorting. Then they can take out the usable part and then recycle it at the 6th shop. And after that, they can ship it to the collecting point, and then eventually to, at the moment, still relying on landfill, but in future, it will rely on the incinerators. I will describe it later on. So in the next few years, we have some timeline. Next year, 24, we will start the municipal waste charging scheme. Everyone has to pay for disposing your waste. And also, we will regulate the disposal of plastic tableware. Okay? And then eventually, we will develop more waste-to-energy facility. Why waste-to-energy? Because the way we see it in the circular economic point of view, there's no such thing as waste. Every piece of waste are resources, okay? You can make use of it to turn it into something useful. And that's why we want to embrace the whole idea of circular economy into our waste management. And if you build proper treatment facility, you can turn the waste or this unused material into useful green fuel, either in liquid form or gas form, or waste to electricity, just like traditional incinerator. So this is how we treat our waste in future. We will no longer dump it into the landfill. And in our plan, we want to close all the landfill by 2035. Okay, we will not rely on landfill to treat our waste anymore by 2035. That's the current plan. And in order to do that, we have to build more waste facility. So when you treat the waste, you have 3 types currently of technology. Incineration, that's when burn it and use it to generate power. Gasification, that means you high temperature gasification, you disintegrate the material in such a form that they become liquid and solid form. You separate it, and then you extract the usable gas like hydrogen, methane, okay? Anaerobic digestion is a biochemical process. Basically, you ferment the waste, like the wastewater, in particular organic waste. You put it in a tank for a number of days. The anaerobic digestion can actually release methane and ammonia eventually. You also have to harvest this type of waste gas and turn it into something useful. Now, currently in our landfill, they simply burn the landfill gas. They don't use it. But the landfill operators now start a trial project to recover this landfill gas and turn it to something useful in future. They already start this project. And the T-Park is already in operation. O-Park 1 for organic waste is also in operation. I-Park 1 is under construction. We aim to start the operation in 2025. It's quite beautiful. This is the chimney. It's like the shape like a yacht. Okay, and then we are also planning and building the second O-Park 2, the second organic plant. Finally, one more piece of legislation I have to do is about Kigali Amendment. You may not, I'm not sure how many of you heard about this piece of legislation. It's part of the Paris Agreement. It talks about hydrofluorocarbon, HFCs. What is this compound? You have it at home. Exactly. It's a refrigerant. This type of HFC has a greenhouse gas potential of over 1,000 times of CO2 to 10,000 times of CO2. So that's why under the Kigali Amendment, we will have to start phasing down the production and the import of this type of HFCs. So in future, if you look at, Hong Kong has to follow the blue line. That's at the moment, we have an imminent timeline. Before 2029, I have to reduce at least 40% from my baseline level. So how I'm going to do it? Next slide, but this slide just show you who will be affected. If you use one of this equipment, you will be affected. How will you be affected? Here, Because my first strategy is to impose a quota system. That means the importers will be licensed and they could only import a certain amount of this type of HFC every year. And you think about it, I have to reduce, the first cut is 40%. I could not cut 40% of my equipment, isn't it? Or your equipment. And where are you going to find the refrigerants? It's not just you have money, you can solve the problem. You could not import it. Okay? Simply, you could not import it. So how are you going to do it? Go to strategy 3 first. Encourage recycling. You can use reclaimed refrigerant. Reclaimed refrigerants is not subjected to quota. Okay? You can buy reclaimed refrigerants from outside. That will get around the problem before we enact strategy 2. You migrate your system from the current high GWP refrigerant to low GWP refrigerants equipment. So we want to make use of these 3 strategies in future to enable the society to gradually transform from relying on high GWP refrigerants to low GWP refrigerant in probably 15 to 20 years' time, because it takes time to change the equipment. And my talk is about this. I finished right here. Thank you very much for your listening attendance. And we still have some time for Q&A.
Thank you so much.